I have talked about different versions of the Blender game engine in a few videos now, but I haven't spent much time going over the raw stats for each engine. Out of these engines, which one actually delivers the most performance, since performance is heavily criticized, especially in UPBGE's newer versions. For these tests, I've created the same scene in every version and engine. This way, I can get as accurate of a result as possible. The whole scene I'm rendering is 1 kilometer squared and has 3.3 million vertices. I also just want to say that this test is going to be going over the rendering capabilities of these engines. This means things like computing logic, animations, and effects are not demonstrated. Though if you would like to see me cover those things, let me know in the comments. For UPBGE 2.5, I have 3 versions. One that is not optimized, one that is optimized, and the last one that is optimized with shaders. With no optimization, you can see even the viewport is slowing down. This is because all my objects are separate meshes and haven't been combined into one mesh. Despite this though, when I'm in the open clearing of my map, I still get about 80 FPS. I do want to note that I'm running the game with no frame limit, and no VSync to show accurate FPS. This is generally not advised when making a proper game in this engine, since the bullet physics engine is tied to the FPS. And without some changes to the code, it could cause physics in the game to not act properly. Things change pretty quickly as I enter the forest, however. As you can see, my frame rate has dropped from a solid 80 down to the low 50s, and is most likely due to the shadow calculations for every single object. Moving on, I have another scene, but this time I've optimized the objects by combining them together, and you can already see the viewport is much smoother than the last one. When I press play, you'll also notice a much higher frame rate. Out in the open, I get just over 200 FPS, and in the forest, I was getting a good 80 FPS. Before it crashed. This is just a fact of life when using these engines. I did a second run and found a low of 55 in the thickest part of my forest. I threw on some GLSL shaders to see how the performance would change, and to my surprise, I was still getting some very good frames per second, with some highs around 150 and the lows going to the mid-50s and 60s range. Overall, I was very happy with the results of UPBGE 2.5. I would also like to note that there are more ways I could optimize the environment that I didn't do in these tests, because I just wanted to see how the engine performs right out of the box. Just try to keep that in mind as we go forward. UPBGE 3.61. Right off the bat, you'll notice that the newer UPBGE viewport is much more optimized, but when I start the game, this is not the case. I got a staggering 16 FPS in the open portion of my map, and I dropped down to 13 going into the forest. This may be normal for the Nintendo Switch, but on PC this is pretty unplayable. Just to give 3.61 a chance, I tried to use the standalone player, but got the same results. So let's move on to the optimized version and see what we get. Right away, when I was loading the game, I was able to triple the FPS. In the open, I was getting around 80 to 90 FPS, and in the forest, I was getting around 50 to 60 FPS. This was pretty surprising to me since I thought I wouldn't get over 30 FPS from my previous experience using the newer version of UPBGE. This was even with volumetric lighting. I did get a crash on this test. Having this many objects combined into one mega object just adds more opportunity for a collision error. A scene of this size should be split into chunks, that way UPBGE can convert physics of the combined objects a little more effectively. With that being said, let's move on to our next contender in the lineup. Armory3D is a very interesting version of the Blender game engine. Unlike the other engines in our lineup, Armory uses the HAX programming language to trigger logic and events, unlike Python that the other versions traditionally use. This means performance is much more consistent than the other versions. That being said, this also means that compile times are much higher, and you can end up spending quite a bit of time just waiting for your game to load between edits. This also gives Armory the ability to export to more platforms than any of the other versions of the Blender game engine. Anyways, let's get back into my findings. Starting with the process of setting up a scene in Armory. This process is much more difficult than setting it up in any of the other versions. Just getting these shaders to populate properly was a process all on its own. This included me having to change some of the engine render settings for the textures to look right. Also, some of my grass shaders did not load properly, so when you see a black plane, that's why. After some tweaking of the settings, I got everything looking more or less right. Setting up the character controller was a pretty big challenge, since it's not quite as straightforward as UPBGE or Range. I was able to use similar logic that I did in UPBGE, but for the camera look, that was a different story. I ended up converting the mouse input into rotation math. Then I used the output to rotate the camera, and the player hitbox. Then I used some math clamping to limit the rotation so the camera couldn't rotate all the way around the player. Now for performance, I ended up just optimizing the map right away since it was completely unplayable right off the bat. But after I got everything working, it played really well. I then made a custom FPS counter so you can see the performance in real time. The only thing I didn't do for this version is adding proper physics to the game. I just didn't have the time to mess around with it, since it's a whole nother process to get working. I then messed with some of the post-processing and added some volumetric fog for fun, and this was the end result. The performance never went under 100 FPS and was the most consistent out of all the engines. It just took the longest to set up. Range 1.5 is currently the most up-to-date release available for free for the public. In my unoptimized scene, the viewport performance was very similar to UPBGE 2.5, and is very slow in the render view. When I played the game, I got a solid 30 FPS in the open part of my map, and it stayed consistent until I got into the very thick part of the forest. At this point, it dropped down to the 20s. So let's see how it does after I do some optimization, as I did with the other engines. Right out of the gate, FPS was in the mid to high hundreds, but I noticed something new. The rasterizer was off the charts high, ranging between 70 to 95% before crashing. I found this interesting since my legacy UPBGE test stayed around 25% for rasterization. From my previous projects I made in Range, I found this to be very shocking, since I always had better performance in my personal projects. I also want to stress that all the settings I used are all the same, so it's not something I did for the Range project. UPBGE 2.5 and Range are very similar, and hardly anything needs to be changed when converting the projects. Overall, I had a great time testing all these engines, and in the process of making this video, I learned a ton about each of the engines and how they react with so many objects in the scene. In the future, I'd also like to do more tests with physics, animations, and the way logic affects performance of the game. Let me know what you think of these findings and what your favorite version of the Blender game engine is. With that said, I've been Lox, thanks for watching, and have a great day.